Higgs field, take two. Okay. So I have gathered y'all here to explain what the Higgs field is. So, a good tens of years ago, we developed a super equation called Newton's equation, and it can calculate anything from why the sky is blue to how much energy is stored in a tree. But in this equation, a very important equation within it, it contained a variable, h, and this stood for Higgs field. And essentially this variable was made just to give whatever was calculating mass, including the electrons, because back then electrons were supposed to be massless. But with new technology, we actually weighed these electrons, and they do have mass. So we built LHC, a Large Hadron Collider. It was finished in July 4th, 2012. And the reason for building this Large Hadron Collider was to simulate 1/1000th of a second after the Big Bang by stripping hydrogen atoms of their electrons and crashing them together at the speed of light. From this, we discovered the Higgs boson. The only reason for the Higgs boson is to prove that the Higgs field is real. Now we can start explaining why electrons, which were supposed to be massless, have mass. So what happens is electrons move two ways, right and left. So as the electron rotates right, it has no mass. As it rotates left, it does have mass. What this Higgs field does is it strips the electron of this energy and it gives it back. Once it gives it back, it has mass, which makes it rotate left. As it rotates right, it doesn't. This creates a duality in the electrons. So this is why electrons have mass, and they tend to teleport through things, because as it's rotating right, it has no mass, because of this constant hypercharge that the Higgs field gives. Now, the scary part is that the Higgs field has duality too. As the electron can move left and right, the Higgs field can become at its present state, which is stable. It's holding everything together. But it can also turn into its evil twin, the ultra-dense state of it. Such as water, its molecules are separated. It's liquefied. But as its second state, it becomes ice and ultra-dense. So does the Higgs field. If this Higgs field is to turn ultra-dense, all of the matter that's surrounding will essentially disintegrate. Luckily for us, the Higgs boson is pretty large, specifically 126 GeV. It is the equivalent size of a DNA molecule. This sounds small to us, but compared to other particles in physics, it is actually very large. And the larger that particle is, the less likely it is to change. So we are all living in a knife's edge between our present stable Higgs field and the ultra-dense apocalyptic Higgs field. So, YOLO.